So if you need to divide these two things, this is a problem well suited for something called synthetic division. Synthetic division happens when you have a linear factor you're trying to divide out like this. And so basically here's how it works. You take the root of the divisor, which means the number that would make your divisor equal 0, and you put it in a little bracket so you can just kind of highlight it. And then you take the coefficients of all the descending powers of the thing you're trying to divide. We're trying to divide this by this. So I'm going to write the coefficients down here. I got a 2, I'm putting a 0, a -3, a 7, and a -6. And you might be mad because you're wondering where the 0 came from, but it's because I needed all my descending powers. I have x to the 4th right here. I don't have an x to the 3rd that's missing, so there's a 0 in front of that x to the 3rd. I have x to the 2nd, that's -3, x to the 1st, so I needed to have that x to the 0 to have descending powers. And now the way you proceed with synthetic division is you make a line, give yourself some space, because you carry down this first number, and then you multiply these two numbers, your root times the number down there to make -4, and put it in the next column. And then you simply add that column, and then you repeat that process. Multiply your root times the number at the bottom, that makes a +8, and then add that column. Multiply your root times the number at the bottom, and then add that column. And then do it once more, and you get 6. Add that, and you get 0. So here's how you write your final answer. You started with x to the 4th. You're dividing it by an x. So we're going to take that 2 and say it's 2x to the 3rd, because the power got reduced by 1. So that makes the next one -4x squared. Makes a +5x, makes a -3. And normally this is the remainder, but in this case, there's no remainder. So that's what it looks like with synthetic division. And another way of thinking of what's happened here. We started with this polynomial. Started with this on the left, but then we saw we could divide an x + 2 from it. And this is what's left over after you divide out that x + 2.